Paint house problem that we are going to discuss today. Let me just write it here. So there is a famous Leetcode problem. Okay. So what is given here is there are n number of houses. So I have taken only 3 houses which are presented in the rows, and they are colored with 3 colors. Okay, red, green, and blue here. There can be more colors also. So what you have to find out is like color all the houses uh, with the minimum cost in such a way so that the first house, or like the nth house, let's say this house, if it is colored with color red, then the previous house cannot be colored with red, so it can be either colored with green or colored with blue. Okay, now if it is colored with green, then previous one can be colored with red or blue, like anything but not the same. So two consecutive houses cannot be colored with the same color, in short. Okay, so let's see the problem at first, and I will remove the solution for now. So there are n houses. So here there are 1, 2, 3 houses where each house can be colored with red, blue, or green. So these things are limited here. It can be more also, but here it's told that it's only three: red, green, and blue. Okay. Now the cost of painting each house with certain color is different. It's 17 to 17, which is different. For house 1, you have to paint all the houses such that no two adjacent houses same color. Okay, so this I already said. The cost of painting each house is represented by the matrix cost. So for this it is 17, for this it is 2. Cost of painting house 1 with red, house 1 with green, and house 1 with blue. Okay, now cost 0 0. Yeah, this they have explained this. Return the minimum cost to paint all the houses. So basically this is a DP problem. Okay, and how we can solve it is I'm directly going into the explanation of how we can solve it and not explaining the why it is a DP. Why, like, if a problem has to be a DP problem, it's solved by dynamic programming, then it has to have optimal substructure and overlapping subproblems. Okay, if you know the basics of DP. If you don't know the basics of DP, you can uh, go and watch any other videos on YouTube. Now let's see how to solve this. So at first, the first step is to solve it. The Using DP is to find the DP states. Okay, so for this we have to find the DP states, and the second step is to find the recurrence relation. So what is the DP state? It is the, like, definition of what is the meaning of DPIJ, and I and J are the states, or I, J, K, L, whatever. There can be n number of states. Okay, so here we can tell is that DPIJ, let's say we are solving it with a 2D DP, and DPIJ denotes minimum cost. Okay, listen this very carefully. So DPIJ, let's say this is DPIJ, DPI1. Why 1? This is because zero based indexing, 0 through first row. Okay, so DP1 and then J is this column. So DPIJ is cost to minimum cost to color, like all the houses till now, I houses, because it is in the ith row. So minimum cost to color I houses with jth color in the ith house. So this is the ith house, last house. Okay, jth color in the last house also, you can say. So if I have to choose this one, right, if I have to choose this one, this color for the ith row, then what I can't do is I can't pick the previous row with the same color. So it cannot be 2. Other than 2, it can be anything, like it can be red or it can be blue, but it cannot be green because I'm picking green here. Okay, so this is the definition of the DP. Or if I say, let's say I'm saying this, so what can be the color of this? This can be The color of this can be red, like I'm saying the DPI1. So we are picking red for this, and then what we're saying is that the previous row cannot have red. It can have either green or blue or whatever other color is there. So minimum of all this, or in here you will actually have the minimum of all this DPI minus 1j. Okay. So this is DPI0, this is DPI1, and this is DPI2. Same for here. So we'll have the previous computed values here in the DP. So at first, this is, if this is DPI1, this is this is DPI0, this is DPI1, and this is DPI2. So you can consider that there are many other states before also. So here we have only taken 3 houses. You can consider there are many other houses, and in here when I take choose red color for this house, then I can find the answers to the previous houses, whatever there are, n number of houses, let's say, before this. So you can find the answer for this here. So what is the answer for this? What is the definition of this? It's that the cost of coloring all houses, with green being the color of the, like, I minus 1th house. Here it is the cost of coloring all whatever houses are there before this, like n number of houses, last 10 houses or last I minus 1 houses, with blue being the last, like, color of the I minus 1th house. So you can take the minimum of this one, this one, this one, and all of this. The minimum of all this is cost of coloring last I minus 1 houses. Okay. So let's see what we have in the definition here. Here I've stated the DP states, and it is the minimum cost to color first. It is the minimum cost to color minimum first I houses with jth color in the ith house. Okay. And reconciliation we have to see, which is dpij equal to color ij plus minimum of dpi minus 1 j minus 1. Let's save this one. What is the cost to color first I houses? Here let's say the first n houses or I houses with color blue for the ith house. So I'm fixing this one has to be blue. So if I'm fixing this, I just cannot take this 5 anymore, because this 2 will be same color then. So I have to take either this column, so I have to take answer for this or this or this, anything. So which one will I choose? I will choose the minimum, because that is what I am doing in the reconciliation. So minimum of dpi minus 1 j minus 1 and dpi minus 1 j plus 1. So I have considered that this is here, there can be another color, but here there is no other color. So all, so here I have taken only for 2, because there are only 3 colors, so remaining only 2 colors are there. If I don't take this color, then there are remaining 2 colors. But if there are, let's say, n m number of colors here, so you can take all minimum of, except this one, the one on the above it, we can take all minimum for all, and then this value. So this is dpij, and the answer is minimum of all this dpij. Why it is the minimum of all this answer? Like, why is this one the answer? This one is the answer because this one gives the value, dpn minus 1 0 gives the value when the color is 0th color and when the color is first color for the last row. But like for the last house, the color can be anything. It can be either red or green or blue. So when the color is red, then some answer is there. When it is green, then some other answer is there. When it is blue, then some other answer is there. And you have to take the minimum of all this to get the final answer. Okay. So let's see the code a bit. So here it's only for 3 houses, so it becomes a smaller version of the problem and limited number of colors. So it's not 3 houses, I think it's n houses only, but colors are 3. So there are only 3 colors, but there can be more colors also. The problem remains the same. Okay. So here I have taken it directly. I have not taken the jth loop because only 3 colors are there. So for columns we can do it directly. So here I have done it directly. I have not taken any other loop. But if there are m colors, then you have to run a loop. Okay. So at first this is the color matrix. I have renamed it to A, and this is the number of rows, number of columns. So number of rows means number of houses. Okay. So first house 1, house 2, house 3. There are 3 houses here, so number of rows is 3 and number of colors is fixed, so you can also take it as fixed, but I have taken it in a variable. Now you have to initialize the DP array. I have taken a DP array with n rows and m columns, where n is the number of houses and m is the number of, so this is houses and this is colors for each house. Okay, so how many colors are there? And first row is same, so first row we have taken it as the basic, this one, it will be the minimum. Okay, so minimum of this. So imagine that if there is only one house. Okay, if there is only one house, this is the base case. So what will you color it? You will color it with the either red, green, but which is the minimum cost, you will color it with that one. So simple. You will just take the minimum for first row. So we have initialized the first row as this one. Now from the second row for house, so this TPI0, what is this? This is like coloring here for ith house. So here we are taking as a second house, you are coloring it with 0th color. Then we are taking the cost directly, so you are taking the cost directly, and then you are taking the minimum of all this from the other on the previous row. On the previous house, you cannot color it with the same color. So this is the concept. So you are doing it as minimum of dp of I minus 1 1, because this is a 0th color, so you can take 1 or 2, first color or the second color. Okay, so next is you are coloring with the house. If you choose to color the house with 1, then you can take 0th or second. Okay, and if you choose to color it with 2, then you can either take it as 0th or 1 on the previous, whatever is the answer to the previous houses. And you have to color it with AI2 simple, and then you have to return the minimum from the last row of TP. So this contains, what is the last row of definition? Last row definition, it is the same definition as TP definition. Minimum cost to color first I houses or first n houses, because it is the last row. When I equal to n, then it is the last row. So first n houses, which is the answer actually. So minimum cost to part of the answer, because answer is minimum of this one. So minimum cost to color first n houses with jth color on the nth house. So red color on the nth house, green color on the nth house, blue color on the nth house. Okay, so if nth house contains this color, then what is the minimum cost to color n houses? So you have to take the minimum of this one to find the final answer. Okay, I hope this is clear, and if you have any questions, you can comment down, and thank you for watching.